Greetings, students. I commend you for gathering here, and I congratulate you on nearly concluding your final year at the Celestial Helix Institute. Dr. Eris paused to survey the crowd, an assembly of inquisitive learners drawn from the 15 or so races that comprised the known galactic community. You may not know me, so allow me to properly introduce myself. I am Dr. Eris. I served on the First Contact team, which, over the past 4 years, has collaborated with the humans on ushering them into our united group. At this, many of the students began whispering, precisely the reaction Eris anticipated. Humans remained new to much of the galaxy and were a topic of endless discussion. The fact that they came from Sol 3, a Class 12B death world, fueled all manner of startling tales told by and about them. Soon, the room quieted, and a handful of students raised their appendages with that inquisitive eagerness characteristic of final-year trainees. Please reserve your questions for a bit longer. My topic today should address some curiosities, though I suspect it will grant you tenfold more, as studying humans often does. At this, several students performed their respective versions of a nervous laugh, lowering their limbs. A few seconds later, the lecture hall was still. First, understand one universal truth about humans. No unyielding rule can pin them down. While you'll find trends and common behaviors, there will invariably be exceptions that defy each pattern. Soft muttering spread among the listeners, a clear sign that many had heard tales describing the unpredictability humans so often displayed. But that is not the main reason I've come here. I'm here to offer you guidance, and for some, a warning. You see, once the usual diplomatic overtures concluded and we began sharing knowledge with the humans, my medical team discovered something in their physiology that sets them apart from every other sentient species known to us. Dr. Eris allowed a moment of silence. The students, now quiet as stone, seemed rapt with anticipation for what peculiarity about humans would emerge next. There is, as yet, no definitive term for this phenomenon, so I ask for your patience. You there, Eris said, pointing to a bright-faced student in the second row. Could you describe, in basic terms, how our nervous system works? Wearing a puzzled expression, the student answered after a short pause. Our primary brain relays signals through nerves to every body part, instructing them to function in ways that keep us alive and let us carry out required tasks. Why do you ask? Do humans not operate likewise? Dr. Eris nodded and motioned for the student to sit. In a broad sense, humans also send signals through their bodies to initiate movement. However, Eris halted, weighing how best to introduce the nuance. You there, the doctor continued, pointing to another student. Tell me precisely what your body does to pick up that tablet on your desk. The student rose, lifted the tablet, then carefully recounted each step. First, I extended my left car muscle while contracting my right car, lowering my arm. Then I tightened my thol joint to rotate my grasper into position, followed by engaging the Xeron ligament to grip the tablet. Finally, I reversed steps 1 through 3 to lift it. The class, though slightly perplexed, recognized this as a standard explanation, one practically anyone here could provide, even if they did not recall each muscle's specific name. Precisely. Here's the key difference. If I asked a human to replicate that action and then detail how it was done, they would be unable to, unless they had studied their musculoskeletal structure ahead of time. In many cases, humans act as though the sentient portion of their mind flips a single switch, commanding the body to perform an action. Meanwhile, the rest of us must coordinate individual muscles more directly. Many in the crowd now looked thoroughly baffled. Eventually, a student with delicate, translucent wings lifted one in the air. Seeing this, Dr. Eris gestured for her to speak. So if I told a human to lift an appendage over their head, they would simply think, arm up, and it would rise? Eris offered a measured smile. That's an oversimplification, but largely true. The biggest distinction is that they don't even have to consciously think arm up. A specific region of their brain manages that task for them. Sensing growing confusion, Dr. Eris went on. I realize how bizarre this must seem. It confounded me, too, at first. The reason I'm struggling to explain it clearly is because this mechanism is so autonomous that even humans have difficulty describing it. That alone shows how closed off their motor control can be. The first student from earlier raised an arm again. Dr. Eris nodded in acknowledgement. So you're saying humans function more like an automated forge. You submit a request, and the finished product emerges. Meanwhile, we basically craft each part by hand. Eris paused briefly, impressed by the student's analogy. Yes, precisely. Now that we've covered the basics, let's discuss how this affects your future work with humans. Beyond this black box nervous system, certain human bodily functions remain entirely outside their direct control. The most prominent example is their heart. Humans call it a smooth muscle, an organ operating with minimal to no input from the central nervous system. A wave of whispers spread through the room. Eris could hear a few students speculating on whether such a system might prove beneficial. So a human's heart does respond to stimuli. If, for instance, the human begins running, the heart rate increases to deliver more blood flow. But unlike us, they cannot will their heart to speed up or slow down at whim. They can only engage in activities that induce that response indirectly. You might wonder why. The answer lies in the overall advantage conferred by their distinct nervous system. Can anyone guess what it might be? Glancing around, Dr. Eris selected a student whose arm shot up quickly. The student proposed, they can multitask more effectively because the parts of their brain we'd use for controlling our body can instead focus on other things. Eris shook their head gently. A logical guess, yet humans are actually poorer multitaskers compared to many members of the coalition. Another perspective is needed. Keep in mind, most every species on Sol 3 shares this trait. After a few seconds of hushed deliberation, a timid student, nudged by neighbors, raised a trembling appendage. Yes? Eris invited. Well, based on what you said, it must serve some survival purpose. But how is that better than precisely controlling one's body to avoid danger? Now the class was edging closer to the heart of the matter. You are correct that ordinarily, finer control does help avoid threats. Yet Terra, that is what they call their home, features a staggering array of hazards. Typically, for a species to forage, hunt, explore, or reproduce there, it must accept numerous risks daily. Attempting to master every muscle for every possible threat is simply not practical. Another student chimed in. So it's like working in a broad general clinic, as opposed to a specialized care facility. The specialized facility has a more focused toolkit, but wouldn't handle the wide range of incoming cases. Eris tilted their head, conceding. An odd analogy, but yes, it captures the point nicely. As with anything about humans, this system can be both a blessing and a curse. Now, can someone summarize how our systems address pain and what effects pain causes us? In the back, a tall student rose to address the group. We feel pain much like other species do. If it reaches an extreme level, we can effectively deactivate the relevant nerve cluster, halting the pain but losing function in that region. Also, if the pain grows too severe, it can muddle or obstruct signals the brain sends, making it difficult or impossible to move that part of the body accurately. Dr. Eris beamed. Correct, and nicely stated. As you might expect, the human system differs once again. Thanks in part to their automatic compartmentalized nerve design, they can keep using and controlling limbs far beyond what we would deem inoperable. They refer to this as pain tolerances. A prime example is that they may continue to move a limb even if it suffers one or several fractures in their internal skeleton. An immediate wave of shock rippled through the class. Several students visibly recoiled at the mere thought of what that pain must feel like, and how damaging the aftermath might be. One student cautiously raised an arm. If they continue using a fractured limb, wouldn't that risk compounding the damage? Eris inclined their head. Yes, often it does cause further injury. Before you ask why humans risk that, I must explain another facet that connects to this question. Owing to the behind-the-scenes nature of their nervous system, humans have relatively little insight into the goings-on within their own bodies. If struck by something that causes a minor fracture, they feel pain in that region, but cannot be certain if the bone is broken or merely bruised. The same applies to many injuries and illnesses. Headaches, for instance, might come from dehydration, overtaxed optic nerves, or countless other factors, but humans often cannot pinpoint the precise cause. Even more frightening is how they can host cancerous growths for years, unaware of it, whereas we would detect such anomalies within weeks. Dr. Eris paused to let the class absorb the implications, then continued. Why then, would humans, especially on a planet as competitive and perilous as Sol 3, evolve with a nervous system that provides only partial awareness of bodily harm? A handful of students seemed ready to propose an answer, but then lowered their appendages, likely spotting gaps in their reasoning. With no volunteers forthcoming, Eris explained, the concise answer is life expectancy. In the earliest epochs of humanity, external threats, predators, environmental extremes, numerous accidents were far likelier to kill an individual than something like cancer. Thus, persisting in motion despite pain and limiting the strain on the conscious mind increased their odds of immediate survival far more than perfect internal awareness would have. By now, worry and fascination warred on many faces. A student ventured a question. So you're saying humans developed their unusual nervous system because their ancestors faced swift, violent dangers more frequently than slow-developing illnesses? Eris offered a small nod, pleased by how adeptly they were grappling with these ideas. Exactly. In our present era, maybe this design is not as universally advantageous as ours, except in specific situations. One of those advantages is the reflex speed humans can demonstrate. Some of you may have heard rumors of humans evading objects that many of us wouldn't even register in time. Often, they later claim they never saw the threat at all. This reveals how their body can initiate action with no conscious input. Such a phenomenon is possible only because they lack the kind of muscle-by-muscle control we possess, so the body simply moves. Just then, an alert chimed on Dr. Eris's tablet, a reminder that the lecture's allotted time was almost finished. All right, I have 2 final points to convey. Let us begin with this. Tapping an icon, Eris activated a screen behind them. I must warn you, the following footage is somewhat graphic, but it's an excellent demonstration of both the human body's compartmentalized nervous design and another peculiarity of their physiology. A video played, depicting a human heart outside its host body. It was supplied with fresh blood from a tube and continued pumping normally in a stark white container. This is a human heart en route to a hospital for transplant into one of their elders who had cardiac issues. Yes, this is genuine, and it happens more often than you might expect. The most astonishing part is that all a heart needs to keep functioning is an adequate flow of oxygenated blood, though naturally it can't survive indefinitely this way. Humans can also, though I dislike this phrasing, make use of parts from others to remain operational. Eris let the video loop once more before stopping it. The doctor nodded to a student who looked like they wished to speak. Have you personally witnessed this operation, Doctor? Eris chuckled lightly. No, I have not, but I have spoken with a human who had this very procedure done. Rest assured, it is quite real. Once the class settled back into attentive silence, Eris pressed on. The final topic applies primarily to those among you gifted with the ability to interface directly with another being's nervous system, those who can feel precisely what a patient feels, Under no circumstances should you attempt this with a human. We know this empathic technique is invaluable in diagnosing other species, yet with humans, it is akin to linking a delicate medical instrument straight into a ship's warp core. The results could be catastrophic. Therefore, you must learn alternate diagnostic methods. Fortunately, humans have developed ample techniques for identifying their body's ailments. Additionally, wherever you might treat humans, a human doctor is typically present to assist you. Dr. Aris paused, scanning the silent classroom one last time. That concludes my allotted time. You may depart now or remain if you have further inquiries. Not a single student stirred. After a moment's hush, it was clear. This question and answer session would stretch well beyond the official lecture, and Dr. Aris wouldn't have wanted it any other way. Dr. Aris paused, scanning the silent classroom one last time. That concludes my allotted time. You may depart now or remain if you have further inquiries. Not a single student stirred. After a moment's hush, it was clear. This question and answer session would stretch well beyond the official lecture, and Dr. Aris wouldn't have wanted it any other way. Dr. Aris paused, scanning the silent classroom one last time. That concludes my allotted time. You may depart now or remain if you have further inquiries. Not a single student stirred. After a moment's hush, it was clear. This question and answer session would stretch well beyond the official lecture, and Dr. Aris wouldn't have wanted it any other way.